I want you to think about a number, 100 billion. That is roughly how many stars exist in our galaxy alone. And when you zoom out to the observable universe, there are 2 trillion galaxies just like it. Wondering if we are alone in all that space is not a modern scientific hobby. It is a question wired into our species. The ancient Greeks debated it. Philosopher Epicurus wrote in 300 BC that it would be absurd if Earth was the only world to produce life. For centuries, asking that question seriously was dangerous. In 1600, the church burned Giordano Bruno, partly for insisting the stars had their own planets. Today, we build machines to answer it. We started locally, sending rovers to scrape the barren, rocky surface of Mars. We sent probes past the cracked ice sheets of Europa. We analyzed the water plumes shooting out of Enceladus. And after decades of listening and searching, we have found 0 confirmed biological signals. The statistical likelihood of life in the cosmos is entirely contradicted by a terrifying, unbroken silence, at least until 2025. The James Webb Space Telescope pointed its mirrors at a planet 120 light-years away, called K2-18b, a world sitting in the habitable zone of its star, and it detected an anomaly. We did not capture a loud radio broadcast or a structured message. We detected a faint, highly specific chemical trace floating in the planet's atmosphere. Deeply cautious, career-conscious scientists looked at the data and struggled to explain it without biology. They are now publishing peer-reviewed papers using the exact phrase they are trained to avoid: potential biosignature. The deepest philosophical question in human history has crossed over from a thought experiment into a measurable physical data point. Reaching this moment required a massive evolution in technology. Missions like the Kepler Space Telescope spent years staring at single patches of sky, proving that planets are a standard feature of the cosmos, and the universe is saturated with rocky and oceanic worlds. In 2019, the Hubble Space Telescope hit a critical milestone. It detected water vapor in the atmosphere of K2-18b, elevating it to a prime target. But to identify specific compounds, we needed the James Webb Space Telescope. It operates as the ultimate chemical detector. This diagram illustrates how we use a technique called transmission spectroscopy. As a planet passes in front of its star, some of the starlight filters through the planet's atmosphere before reaching us. Different molecules absorb specific colors of that light. By analyzing exactly which colors are missing from the spectrum, scientists can identify the precise molecules floating in a planet's air trillions of miles away. Webb does not take literal photographs. It reads the undeniable chemical fingerprint of a distant world. When astronomers analyzed K2-18b, they found expected gases like methane and carbon dioxide, but the data also flagged an anomaly: dimethyl sulfide, or DMS. On Earth, DMS is the molecule responsible for the distinct smell of the sea. It is produced entirely by marine phytoplankton, microscopic life floating in our oceans. In our biosphere, you simply do not find significant quantities of this compound without an active biological process releasing it. K2-18b is what astronomers call a Hycean world. It is completely devoid of land masses, featuring a thick hydrogen sky crushing down on a violent ocean. It is an environment totally hostile to human experience, yet its global ocean is exhaling a gas that strongly suggests it is alive. The scientific method demands severe skepticism. Researchers at institutions like Cambridge are aggressively challenging the data, raising valid concerns. The first major hurdle is the detection itself. The DMS signal sits at the absolute edge of Webb's detection limits, hiding deep within the instrument's noise. Then there is the abiotic counterargument. Chemists are debating whether extreme, undiscovered atmospheric reactions could forge DMS without life. We also have to account for our own Earth-centric bias. We might be applying our local biology to an alien chemistry and seeing a mirage. But despite all the attempts to disprove the finding, the tension continues to rise. With every subsequent transit observation, the DMS signal appears to get stronger. Science demands an impossibly high standard of proof before confirming a discovery of this magnitude. Right now, the biological explanation refuses to die. Let's assume the signal is real. It would suggest that Earth is not a singular accident. If life could emerge twice on 2 worlds as Earth and K2-18b, It implies that biology may be far more common than our quiet solar system suggests. This forces us to confront the Fermi paradox. Decades ago, physicist Enrico Fermi posed a question. If life is a natural, frequent consequence of the cosmos, where are all the civilizations? This cosmic timeline highlights a major problem. The universe is billions of years old. Older civilizations should have filled the galaxy with radio waves. Confirming K2-18b implies a great filter, a barrier reliably wiping out life before it becomes intelligent. We are actively waiting for the final measurements to confirm or deny this signal, pulling thousands of years of questioning out of the dark. If the silence is officially broken, the night sky transforms. Every star becomes a distant, living neighbor, trapped in the exact same cosmic mystery.